This video will take you through common preventative maintenance procedures for parameter conditioning units. Here we'll cover basic verifications, in-depth technical inspection processes, cleaning, and periodic maintenance procedures. Start by making sure the unit is on and operational. Make sure that the electrical power applied matches the data plate. Ensure that a proper external protector is in place. Verify that process water is properly connected. If applicable to your machine, inspect the external process water filters. Make sure that the condensate drain is connected to an open drain. Ensure that the sump pump is fully functional. And document the system configuration using SmartLog. Document the chamber's mode of operation. And document the chamber's set points. Verify if the chamber controls air temperature. Document the air heater output percentage. Verify if the chamber controls water temperature. Document the water heater output percentage. Verify if the chamber controls RH. State the use of the chamber, long-term or short-term study, QC tests, or laboratory. Document the tolerance and time limit allowed out of condition, and be sure that the customer approves of the same. If the customer indicates any past or current problems with the chamber, record those notes. We'll now go into a more in-depth look at verifying component functionality for maximum heating. Start by documenting the SmartPad control mode. Configure the SmartPad for 2-temperature control mode. Adjust the water set point in order to provide 100% water heater output. Adjust the air set point in order to provide 100% air heater output. Using a multimeter, check and record the air heater current for each air heater present. The heater or heaters should register typical full current value. If you are unfamiliar with the expected current reading, you can calculate this by using the universal Ohm's law calculation. Water heater amps. Using a multimeter, check and record the water heater current. Water pump amps. Using a multimeter, check and record the water pump current. Blower motor amps. Using a multimeter, check and record the blower motor current. Compressor amps. Using a multimeter, check and record the compressor current. If it is at a 3-phase power supply, verify the hot gas bypass valve operation. Line amps number 1. Using a multimeter, check and record the main line current for each phase. Then verify that the air bypass damper is in the full bypass position. Document the rotational position of the actuator, CW or CCW. Now we're going to verify the component functionality for maximum cooling. Adjust the water set point in order to provide 0% water heater output. Adjust the air set point in order to provide 0% air heater output. Air heater number 1 amps. Again, using a multimeter, check and record the air heater current for each air heater present. This time, the reading should be 0. Water heater amps. Again, using a multimeter, check and record the water heater current for each air heater present. This time, the reading should be 0. Again, using a multimeter, check and record the water heater current for each air heater present. This time, the reading should be 0. Line amps number 1. Using a multimeter, check and record the main line current for each phase, if it is a 3-phase power supply. Verify the hot gas bypass valve operation. Then, verify the air bypass damper is in the full bypass position. Document the rotational position of the actuator, CW or CCW. Now we're going to verify component functionality, approximately 50%. Adjust the air set point to equal the measured air temperature. This should provide approximately 40% to 60% air heat output. Verify that the air damper position is correct. Test the low water float switch, if applicable. Record the setting of the adjustable air temperature limit thermostat. Test the adjustable air temperature limit thermostat. Then, restore the dial to the previous setting. Next, confirm condensate valve functionality. And verify that the sump level is properly controlled by the water level control float valve. Next, we'll begin the cleaning process. The machine we are working on is brand new and therefore not dirty, but we will show you the proper areas and techniques for reference. Clean all of the sump surfaces and the internal parts as necessary. Clean the finned evaporator coil, being careful not to fold the fins. Remember that the coil can be blocked between the fins and still look clean on the surface. Pressure washing is typically the only effective way to get the gunk from deep between the fins. Remove the damper and whatever else in order to access the hard-to-reach side of the coil. On vertical units in particular, be sure to remove the top cover on the coil and clean beneath. Be sure to neutralize any acid used and rinse any cleaning solutions thoroughly. Flush the sump with fresh water. Clean the blower area as necessary. Clean the air-cooled condenser and mechanical area as necessary. Next, we will review periodic maintenance items. Note that if your customer is responsible for their own periodic maintenance, please stress the importance of these steps. Inspect the water sump and note the appearance of the water and sump surfaces. Inspect the blower wheel. Inspect the condenser flow valve for any rust or corrosion. Verify that the water spray nozzles are spraying uniformly. Inspect the air and water heaters for surface corrosion. Inspect the water-cooled condenser inlet filter strainer if applicable, and clean and replace as necessary. Note the condition of the blue fur spray eliminator filter. Next, we will demonstrate an operational verification. Configure the smart pad for the previous mode of operation. Configure the unit to operate at the customer's conditions. Continue logging with SmartLog and observe proper operation. Record the most recent controller sensor calibration date and record the most recent replacement date of the UV lamp. Finally, note any aspect or components of the system that are inaccessible for cleaning and/or need certain preparations to be made for cleaning or servicing in the future. This concludes the presentation of the preventative maintenance procedures for parameter conditioning units. Thank you for watching.